And now that we've defined each of the variables in the continuous compounding formula, let's take a look at it in action. So here's our same scenario. We're planning to buy a pickup truck in 5.5 years, and we need the money for a down payment. And to accomplish this, we want to deposit $5,000 into an account that earns 2.5% APR. When it's time to buy your pickup, what is the maximum amount of money that you could have? And when you see that kind of wording, maximum amount, that's a key to you that you probably want to use the continuous compounding formula. And since it says maximum amount, I'm thinking continuous compounding, but I do have to tell you there's one other formula that might have maximum in it. So we're talking here about the maximum amount of money that you could earn on an investment. So money that you put into the bank and save in order to make some money on. And so that's the maximum amount of interest. And so that'll tell you continuous compounding. So write out the formula. So we have A equals PV, the present value, times E to the RT, and PV is going to be for this problem $5,000. And then we have E, that's just the exponential growth constant. And we put our rate, which is 2.5%, so we can put it in as 0.025. Remember, you can also use 2.5 and then put that percent symbol after it. And then how many years? We have 5.5. So remember how we had to think about if our account was being compounded annually, if we could get interest halfway through a year? Well, if it's being compounded instantaneously, then it doesn't matter how long we have money in an account, it's going to get interest up until the instant that we withdraw it. So we can definitely do 5.5. We don't have to round down at all for this one. And then I want to find out what that exponent is first, because remember, by order of operations, exponents come before multiply. And in my exponent, I need to do that multiplication so that I can take e to this power. So 0.025 times 5.5. 0.1375. And I'm just going to record that so I can see what I'm doing later. When I come back and look at my notes, I'll remember, oh yeah, I just multiplied that out. And now the next thing I have is 5,000 times e to the 0.1375. And so still we're working on that exponent next, e to the 0.1375. So I need to, since I already have the 0.1375 sitting on my calculator, all I need to do is put in that e first. So I'll do second ln, and now I have e to the, and now I can do the answer. So second minus, and then enter. So e to the 0.1375 gives us 1.1474, and it goes on. And the last thing I need to do is the multiply, so times 5,000. And I'm going to round to 1 penny because I have an 8 following. The maximum, $5,737.01. Okay, and remember, you want to make sure that you leave all the calculations on your calculator as you are working so that you don't lose precision and you can end up being off by $1 or more. So we want exact answers, so we're going to leave all the values on the calculator until the very, very, very last step and then do the rounding. So the question is the continuous compounding any better than the other types of compounding we did on page 9? So let's go back. All right, so for the 5.5 years, with the monthly compounding, we're getting $5,736.19, 36, so it's just slightly less, and then $5,736.79, so it's just barely more what we're getting with the continuous compounding. So we can say that here, and this is supposed to be page 10. Yes, just barely. And what mathematicians have found is that as you make the number of compoundings greater and greater, which means the distance between from when you compound one time to the next is shorter and shorter, so that you're doing it every instant, that the formula doesn't have to change very much. It just suddenly reverts to this formula here that we call it the PERT formula, because if you leave off that V, it's P-E-R-T. So this PERT formula is going to give you the best result. It comes very, very close to this value. So we use that formula to find out this is the maximum that you could get with any type of compounding. And so that's our answer here. And it does give you just barely better than daily compounding.